Good evening, friends. Welcome to Unacademy GATE MEPIXC. This is your educator Apuroop, and you are watching the lecture series of machine design. This is lecture number 16, Design of Bearings Part 2. I welcome all of you. Good evening, Dibyanshu, good evening, Ankita, good evening, Arpit, good evening, Vikas. Welcome, everyone. Welcome. So, beta, you are watching the lecture series of machine design where we are going to complete the entire syllabus of machine design. We have almost completed 50-60% syllabus, only a few more chapters left. And this is the part of 100 days crash course series which we started on 1st of October. And I have already completed one subject in that series, and that is strength of material. You can watch the entire playlist of strength of materials. And this is the second subject in that series, machine design, and I have completed almost half of the syllabus, even in fact more than half of the syllabus, only a few chapters left. Welcome all of you. Good evening Amol, good evening Naveed. Okay, so beta, before we start, please hit the like button and make sure that you share the link with all your friends so that maximum number of students can get the advantage of these classes. मैं चाहता हूं कि आप सब लोग एटलीस्ट अपने अपने ग्रुप्स में जाकर इनको शेयर कर दीजिए ताकि ज्यादा से ज्यादा लोगों तक ये लेक्चर्स पहुंचे. These are completely free of cost lectures. We are not asking anything from you, only your love and support in the way of a one like and one share. So thank you so much if you have already done that. Good evening. Okay, so if you are watching me for the first time, let me introduce myself. My name is Apuroop Rao, all India rank 320 in GATE Mechanical. I have done my MTech from IIT Kharagpur. I got a call from IOCL, but I never went for the interview because I always wanted to be an IITian. So I went for IIT Kharagpur for my master's degree. I did my master's in mechanical systems design. Then in my final year, I was recruited by Mahindra & Mahindra, and I was placed at their research and development center called Mahindra Research Valley, which is located in Chennai. All the cars and tractors of Mahindra are designed there. So I worked there as deputy manager for 2 years, but then I quit my job and I started teaching. So I've been teaching for more than 6 years now for GATE and ESE students, and I teach subjects related to design. Strength of material, machine design, engineering mechanics, and theory of machine. You can watch my entire playlist of these subjects here on tinyurl.com/Apuroop10. If you want all the free lectures plus notes plus ebooks, then all you have to do is go to this tinyurl.com/Apuroop10. You will find all my free lectures there. Engineering mechanics, strength of materials, machine design, theory of machines. Recently, I've started a crash course on theory of machines also. I'll tell you about that. So you will find all of that here, tinyurl.com/Apuroop10. Just open your web browser and type this, tinyurl.com/Apuroop10, just like facebook.com, youtube.com, and then enter, and you will see this page where I have uploaded all the ebooks of different subjects, and I have uploaded these Excel sheets which contain the links of all my classes. Whatever classes I have taken, I have organized their links in these Excel sheets subject wise, so that you will not have to search for anything. So everything is well organized in these Excel sheets. सब कुछ इन Excel sheets में organized तरीके से रखा गया है ताकि आपको कहीं भटकना ना पड़े, कुछ ढूंढना ना पड़े. Okay, so if you open any of these Excel sheets, you will find that I have given lecture by lecture all the links of classes, ebooks, everything is here. Everything is here, well organized, and it contains the entire syllabus of that subject. So if you are preparing on your own, then beta these lectures will really help you. अगर आप अपने खुद से गेट की प्रिपरेशन कर रहे हैं या किसी भी कॉम्पिटिटिव एग्जाम की प्रिपरेशन कर रहे हैं, तो ये लेक्चर्स आपको बहुत मदद करने वाले हैं, क्योंकि पूरा का पूरा सिलेबस मैंने कवर किया हुआ है स्ट्रेंथ ऑफ मटेरियल, मशीन डिजाइन, इंजीनियरिंग मैकेनिक्स एंड थ्योरी ऑफ मशीन का. मैंने अभी रिसेंटली थ्योरी ऑफ मशीन की क्रैश कोर्स स्टार्ट की है. सो इफ यू वांट टू फॉलो मी ऑन अनअकैडमी, then all you need to do is go to unacademy.com/@Apuroop. You will go to my Unacademy profile, and in that profile you can see all my special classes which are completely free. ये जो special classes होती हैं ये free होती हैं. Everyone can watch them by downloading the Unacademy app. सिर्फ आपको Unacademy app download करना है और आप सारी classes free of cost देख सकते हो. Okay, and I have recently started crash course on theory of machine. I told you on 14th of December I started this class, and every day I am taking two classes, one at 2 p.m. and one at 3:30 p.m. So if you want to watch these special classes, then you need to download the Unacademy learning app. You need to register yourself and you need to use the code Apuroop10. Whenever you are watching the special classes for the first time, अगर आप special class पहली बार देख रहे हो, अगर आपने अभी recently Unacademy का app download किया और अगर आप Unacademy का special class पहली बार देख रहे हो, then they will ask you to put an invite code. And what will be your invite code? Your invite code will be Apuroop10. If you put this code, then all the special classes will be unlocked. Not only mine, all the special classes, means every educator special class you will be able to see if you use this code Apuroop10. So don't forget to download the Unacademy learning app, register yourself and use this code Apuroop10 in order to unlock all these classes, Where will you find the links of these classes? Again, all my classes, the links of all my classes you will find here only. tinyurl.com/Apuroop10. You don't need to go anywhere. आपको subject wise सारी links जो हैं वो यहीं मिल जाने वाली हैं. tinyurl.com/Apuroop10 में सारी चीजें यहीं मिल जाने वाली हैं. Okay, all right. And beta, if you want to start your preparation with us, then on Unacademy Plus we are launching 2 batches for GATE 2022 and GATE 2023 aspirants from 28th of December. Both these batches will be started on 28th December. Okay, one is known as Evolve batch, which will be for GATE 22 aspirants, and one is known as Ascend batch, which will be for GATE 23 aspirants, and it will be started on 28th of December. All you need to do is take the Unacademy subscription using the code Apuroop10. What will be the advantages of Unacademy subscription? That I will let you know at the end of the class. Okay, I will tell you all about this in detail. What are the advantages of Unacademy learning app? What are the advantages of Unacademy Plus? I will tell you in detail at the end of the video. So if you want to take Unacademy Plus subscription, all you need to do is go to Unacademy app, click on get subscription, choose which subscription plan you want to use. Okay, choose which subscription plan you want to choose. 1 year, 1.5 year, 2 year, but make sure that you use this code Apuroop10. If you use this code Apuroop10, you will get 10% off. Okay, so beta, you can take and whatever subscription plan you want and join these awesome batches, GATE 22 aspirants and all the GATE 23 aspirants. You can also take Unacademy iconic subscription where you are going to get a personal coach who will guide you 24/7. Okay, again, you can use this code Apuroop10 to get maximum discount and to get my personal guidance. Okay, so don't forget to join these batches. Now, yesterday we started design of bearings. कल हमने design of bearings चालू किया था. I told you what are bearings. So bearings are special types of supports in order to support moving elements like shafts, so that there will be minimum friction between them. Otherwise, what will happen? There will be a lots of torque, a loss of power, there will be heat generation, there will be friction loss, there will be heat generation, there will be wear and tear on the surface of shaft if the friction is not minimized. So friction को minimize करने के लिए and in order to support the load of shaft, we use bearings, right? So there are two main functions of bearings: to support the load acting on the shaft and to permit the rotation of the shaft with minimum friction. Minimum friction के साथ rotation, right? Then I told you that there are two types of load coming on the shaft. One is radial load, which is perpendicular to the length of the shaft. This is the length of the shaft. So one load is the radial load, which acts perpendicular to the length, and one load is the axial load, which acts in the direction of the length. Okay, so these are the two types of load. Now in some cases there is only radial load, in some cases there is only axial load, and in some cases there are both radial load as well as axial load. Okay, now majorly there are two types of bearings. अगर आप bearings को categorize करना चाहते हैं, if you want to categorize bearings, then there are two major categories: rolling contact bearings and sliding contact bearings. Rolling contact bearing means the relative motion between the shaft and the bearing surface is rolling motion. Okay, what do we mean by rolling motion? This is rolling motion, this is sliding motion. Okay, this is rolling motion, the motion of a wheel, that is rolling motion, and this is sliding motion. Okay, so beta, if the relative motion between shaft and bearing surface is rolling, so sorry for this, then it is known as rolling contact bearing. And if the motion is sliding motion, then it is known as sliding contact bearings. Okay, so beta, the design process of both these bearings are completely different. Why? In case of rolling contact bearings, due to this rolling contact, there is very less friction, minimum friction, negligible friction. So that's why friction does not play a major role in the design of these bearings. But in these cases, the friction is very high. So friction and lubrication is very important in the design of these bearings. Okay, the entire design process revolves around friction and lubrication. So that's why the design process in both these cases are completely different. So you can say that the chapter of bearings is divided into two parts. There is a separate chapter called rolling contact bearing. There is a separate chapter called sliding contact bearing, and the entire design process is different. Okay, so first we will see the design process of rolling contact bearings, and then we will move on to the design process of sliding contact bearings. Okay, so yesterday we started rolling contact bearings. What are rolling contact bearings? Rolling contact bearing means the relative motion between shaft and bearing surface is rolling motion. Why? Because there are rolling elements between the shaft and bearing. शाफ्ट और बियरिंग के बीच में हम रोलिंग एलिमेंट्स लगा देते हैं, तो जब शाफ्ट घूमती है तो बियरिंग के सरफेस पे रोलिंग मोशन होता है, राइट? When the shaft starts to rotate, due to these rolling elements, there is rolling motion. Okay, so beta, the friction is minimum in initially and in the operating condition. In both cases, low starting and running friction, hence they are also known as anti-friction bearing. And this is an important term. You will get questions based on this. Which one of these bearings are anti-friction bearing? So anti-friction means rolling contact bearing. Okay, but there is a disadvantage. What is the disadvantage? The disadvantage is that they are noisy at high speed, and their initial cost is also very high. So that's why we can't use them everywhere. So what are the applications of rolling contact bearing? Spindles of the tools, automobile front and rear axles, and small size electric motors. Okay, now the construction, typical construction, I told you that this is the inner ring, this is the outer ring, these are the rolling elements, and this is the cage in which the rolling elements are fitted. Okay, then we saw that there are two types of rolling contact bearing. Ball bearing, in which case we use the balls as rolling elements, spherical balls, and roller bearings, in which we use these rollers instead of balls. Okay, then there are different types of ball bearing. Deep groove ball bearing, which can sustain both FR and FA. Angular contact ball bearing, again it can also sustain both FR and FA due to the angular contact. Then self-aligning ball bearing, which can align itself with respect to the misalignment of shaft. If there is misalignment of shaft, then it will also rotate and align itself. Okay, then there was thrust bearing, which is used to support the axial load only. Then we saw different types of rolling contact bearing. Cylindrical roller bearing, where the roller is of cylindrical shape, hence it can only sustain radial load. Then we saw tapered roller bearing, and due to this tapered shape, it can sustain both radial as well as axial load. It is just like angular contact ball bearing. Then we saw self-aligning roller bearing, which are known as spherical roller bearing. Okay, these also have self-aligning property. And then we saw needle bearing, when the space between the radial space between the shaft and bearing surface is very less. Agar radial direction में बहुत कम जगह है, then you can't use cylindrical rollers because they need more space. So instead of using less number of big rollers, we use small size needles in a large number. You can see that the size of these rollers are very small, but they are high in number. So that's why their load carrying capacity is greater than roller bearing for the same size. अगर आप size की तुलना करें तो ये बहुत छोटे हैं, but इनकी load carrying capacity ज़्यादा है. Okay, so beta, these are the types of bearings. Now we need to see the design of rolling contact bearings. So there are some parameters based on which the rolling contact bearings are designed. Now you need to first understand that bearings are one of those elements, machine elements, which are not exactly designed. See, bearings are manufactured in large quantities. So we don't design and manufacture the bearings according to our needs. No, bearings are already designed and manufactured in very large quantity. We just choose the appropriate bearing for our machinery. हम क्या करते हैं बेटा, बियरिंग को हम अपनी मशीन के लिए स्पेशली डिजाइन या मैन्युफैक्चर नहीं करा सकते. क्यों? क्योंकि अगर मैं अपनी इफ आई design and manufacture the bearings according to my needs in small quantities, then the cost per unit will become very high. That's why there are some machine elements which are manufactured in very large quantity in order to reduce per unit cost. Example, bearings, bolts. There are a lot of machine elements which are manufactured in large quantity. Bolts are also there which are manufactured in large quantity. Okay, so what happens is, we have already designed and manufactured bearings. Now we just need to choose the appropriate bearing according to our need. Okay, so we need to only see what are those parameters based on which we will choose our bearing. Okay, अब हमको वो parameters देखने हैं जिसके basis पे हम अपनी bearing choose करने वाले हैं. That okay, this will be the bearing suitable for my application, this will be the bearing suitable for my application. So based on which parameters I can choose whether this bearing is suitable or not. Okay, so we will only focus on those design parameters, nahi, the parameters based on which we choose. Okay, so the first parameter based on which we are going to choose our bearing is static load carrying capacity. Now understand, there are two types of loads acting on the shaft. When the shaft is stationary, then the load acting on the shaft is known as static load. What will be the static load? When the shaft is stationary, it is not moving, whatever load is coming on the shaft, acting on the shaft, that will be known as static load. Now if the shaft is stationary, then which load will be acting on the shaft? The weight of the shaft, then the weight of all the devices mounted on the shaft, all these will be acting on the shaft. Even though the shaft is not moving, it is stationary, even though it is not transferring any power, still the weights of all these elements are acting on the shaft in downward direction, vertical direction. So these are known as static load. Now due to this static load, there is deflection, there is deformation in the ball bearing or roller bearing, and this deformation is plastic deformation. Now understand why this deformation is why we are interested in this deformation. Why not we are talking about stress? So beta, stress will be within its permissible value, but the problem is with the deflection, deformation. Why? Because these bearings are supporting the load on very small area. जो bearing है वो load को बहुत छोटे area में, very small area, बहुत छोटे area में ये support कर रहा है. Why? Because there is point contact, there is line contact. So the area, contact area is very less, and if the contact area is very less, then the deformation will be very high. Okay, so beta, that's why the criteria of failure here is deformation. Okay, so beta, this static load that is acting on this shaft is causing plastic deformation in the bearings, okay, in the balls and in the races. Okay, and this deformation will increase with the load. So if you are increasing the load, this deformation is also going to increase. Okay, there will be a point when the plastic deformation will reach 0.0001 of the ball diameter. Now this is our limit. We cannot permit the plastic deformation to be greater than 0.001 into diameter of the balls. ये हमारी maximum limit है deformation की, ठीक है? As you keep on increasing the load, the deformation will also increase. So there will be a load at which deformation will become 0.0001 into diameter of the ball. So this is my maximum limit. I cannot cross this limit of deformation, otherwise I will assume that my bearing has failed. So beta, at this limit, whatever the load is acting on the shaft, that is known as static load carrying capacity. For example, मान लो, let's say at 500 Newton, for example, at 500 Newton, the deformation becomes 0.0001 into diameter of ball. So this 500 Newton is now my static load carrying capacity. Okay. So we will calculate what should be the minimum static load carrying capacity for my application, and then I will choose a bearing which has slightly greater static load carrying capacity. For example, let's say according to my application, I calculated that static load carrying capacity should be almost 9.5 kilonewton. So I will choose a bearing which has a static load carrying capacity greater than 9.5 kilonewton, let's say 10 kilonewton. Okay, so my static load carrying capacity required static load carrying capacity is 9.5 and I am choosing 10. So I am safe. Okay, so this is how we can choose a safe bearing for our machinery. Okay, so the first parameter is the static load carrying capacity. Now static load carrying capacity is denoted by C naught. इसको हम C naught से denote करते हैं, and how it is calculated? It is calculated using this equation. Okay, it is calculated using this equation. C naught is static load carrying capacity, and this is the equation of static load carrying capacity. C naught is equal to K into D square N divided by 5. K into D square N divided by 5, where K is a constant which depends upon material. Okay, it is some constant which depends upon material. D is the diameter of balls and N is the number of balls. Okay, now you don't have to worry about this equation. You are not going to use this equation to solve numericals. Okay, there will be no numerical based on this, but there might be theory question. Okay, static load carrying capacity depends upon what things. So it depends upon the material, it depends upon the ball diameter, and it depends upon the number of balls. Okay, so that's all you need to remember. बस आपको इतना याद रखना है और कुछ याद रखने की जरूरत नहीं है. Okay, good evening Dinesh, good evening Vishal, good evening Sweksha, good evening Prem. Welcome everyone, welcome, good evening. Please hit the like button, everyone who is live, please hit the like button, and please don't forget to share the link with your friends. ठीक है, शेयर करना प्लीज मत भूलना, सिर्फ लाइक करके छोड़ मत देना मेरे भाई, शेयर करना बिल्कुल मत भूलना. ओके, शेयर करना बिल्कुल मत भूलना. थैंक यू सो मच अगर आपने ऑलरेडी लाइक और शेयर कर दिया है. ओके, चलो तो बेटा दिस इज द फर्स्ट पैरामीटर. इसके ऊपर यू विल नॉट गेट अ लॉट ऑफ क्वेश्चंस. ओके, स्टैटिक लोड कैरिंग कैपेसिटी के ऊपर यू विल नॉट गेट अ लॉट ऑफ क्वेश्चन. जस्ट रिमेंबर व्हाट इज स्टैटिक लोड कैरिंग कैपेसिटी and remember this equation only for theory question. Okay, there will be no numerical based on this. इसके ऊपर कोई numerical नहीं आने वाला है, इसके ऊपर कोई numerical नहीं आने वाला है. Okay, चलो. Now life of bearing, this is the most important parameter which is used for choosing the appropriate bearing. Life of bearing. Okay, what do we mean by life of bearing? Let's understand. Life of bearing is the minimum number of revolutions that the bearing will make before the first sign of failure. यानी कि see, bearing is used in supporting the shafts which are rotating, right? They are making revolutions. Okay, so beta, the life of bearing is defined in terms of number of revolutions. How many revolutions these bearings will make before failure? फेलियर से पहले ये बेयरिंग कितने बार घूमने वाली है, दैट विल बी नोन एज द लाइफ ऑफ द बेयरिंग, एंड इट इज डिनोटेड इन मिलियन रेवोल्यूशंस. ओके, सो वी नीड टू फाइंड आउट व्हाट विल बी द लाइफ ऑफ दिस बेयरिंग. ओके, नाउ अंडरस्टैंड हाउ द लाइफ ऑफ द बेयरिंग इज कैलकुलेटेड. It is not possible to find the life of each and every bearing individually. Okay, because whatever testing we carry out, we cannot test each and every bearing. जो भी टेस्टिंग होती है लाइफ ऑफ बियरिंग निकालने के लिए, whatever test is carried out to find the life of bearing, it cannot be performed individually for each bearing. So what do we do? In order to calculate the life of bearing, let's say we have manufactured 100 bearings, we need to find the life of 100 bearings. Okay, so what we will do is we will randomly choose 2 or 3 bearings We will randomly choose 2 or 3 bearings, okay, and then we will perform the test. Let's say we have found out the life of these bearings as 10 million revolution. So we will say that the life of these entire 100 bearings is 10 million revolution. Means these bearings will survive at least 10 million revolution. ठीक है, इसका मतलब कि ये bearings जो हैं एटलीस्ट 10 मिलियन रेवोल्यूशंस जो है सर्वाइव करने वाली है. मिनिमम 10 मिलियन रेवोल्यूशंस दे आर गोइंग टू सर्वाइव. ओके, सो दिस इज नोन एज व्हाट? लाइफ ऑफ bearings. Now understand, I have calculated the life of bearing of only 2-3 bearings, and based on that I am saying that the life of all the bearings is 10 million revolution. So is it necessary that all the bearings will have at least 10 million revolution life? No, it is not necessary. Some of these bearings will make 11 million revolutions, 12 million revolutions, 15 million revolutions, let's say 20 million revolutions. So minimum I need is 10 million revolution, and they are making more than 10 million revolution. So very good. That is the advantage of me. Okay. But if one of those bearings will fail before 10 million revolution, then it is a problem for me. Why? Because my requirement is 10 million revolution and it is only making 9, 8, 7, 5 million revolution. So I need to say how many percentage of bearings will survive 10 million revolutions. Is it 50%? Is it 60%? Is it 70%? Is it 80%? This is known as the reliability of life. Reliability of life means what? If I say that out of these 100 bearings, 90% bearings will have at least 10 million revolutions life, then my reliability is 90%. The reliability of this life is 90%, means this data that I am giving you is 90% reliable. So if you use this bearing, let's say you are using these bearings in 10 machines. So if you are using these bearings in 10 machines, at least 90% will be safe, but 10% might fail. So beta, whatever life of bearing we calculate, it is not 100% reliable, because we are only testing a few bearings and we are predicting the life of all bearing. It is not possible for us to predict the life of each and every bearing separately. Okay, so that's why whatever life is calculated, it has some reliability. Now there are two reliabilities at which the lives are usually calculated: 90% reliability and 50% reliability. And the life at 90% reliability is known as average life. The life at 50% reliability is known as, the life of at 90% reliability is known as rated life, and the life at 50% reliability is known as average life. ठीक है, sorry मैं थोड़ा confuse हो गया था. 90% reliability means rated life, 50% reliability means average life. Okay, now understand what is the definition of rated and average life. Rated life means the life in million revolutions that at least 90% of bearings will run before failure. At least 90% bearings जितनी life achieve करते हैं, उस लाइफ को हम क्या बोलते हैं? रेटेड लाइफ. द रेटेड लाइफ मींस at least 90% bearings will be safe. 10% might fail, but at least 90% bearings will be safe. This is known as rated life, and it is denoted by L10 or L90. L10 or L90. Then the second life is average life. What do we mean by average life? So average life means the number of revolutions that at least 50% bearings will run before failure. मतलब कम से कम 50% bearings जो हैं वो इतनी लाइफ अचीव करेंगे. So rated life, average life. Rated life, average life. Now there is a relation between average life and rated life, an approximate relation which is given by L50 is 5 times of L10. L50 is 5 times of L10. This is just an approximate relation, but we use it to find the relation between rated and average life. Okay, So beta, if you have rated life, you can find average life. If you have average life, you can find rated life from this equation. L50 is 5 times of L10 or L90. L10 or L90 both are rated life. In some books you will see they use L10, in some books they use L90. Okay, both are rated life. ठीक है? So beta ये clear है? Now beta, it is not necessary that we will always need rated or average life. In some cases you might need more than 90% reliability. For example, let's say you are choosing the bearing for an aircraft. ठीक है? So aircrafts must have very high factor of safety, very high reliability, because even if there is a small failure in aircraft, a lot of lives will be in danger, right? If you are designing the bearing for a toy, let's say a simple toy, then you don't need a very high reliability. Why? Because even if the toy fails, you can always blame the kid, right? अगर आप खिलौने के लिए बेयरिंग ले रहे हो तो आपको इतना रिलायबल होने की जरूरत नहीं है, क्योंकि अगर वो टूट भी गया, फेल भी हो गया, तो आप हमेशा बच्चे पे इल्जाम लगा सकते हो कि उसी ने तोड़ा होगा, पक्का वही कुछ खेल रहा होगा, गलत खेल रहा होगा तभी टूटा है, वरना सर हमारी बियरिंग बड़ी जोरदार है, हमारी बियरिंग का फॉल्ट नहीं है, आपके बच्चे का फॉल्ट है. ओके, तो बेटा वी डोंट नीड हाई रिलायबिलिटी for toys, but if you are designing bearing, if you are choosing bearing for an aircraft, then beta you can't blame it on the pilot, right? आप पायलट पे ब्लेम नहीं कर सकते कि अरे ये पायलट अच्छे से चला नहीं रहा था इसीलिए टूट गया, या फिर अच्छे से रख रखाव नहीं, सर्विस नहीं कराई होगी सर, आपने सर्विसिंग नहीं कराई होगी इसलिए टूट गया, because a lot of lives will be in danger. So we need very high reliability. So in some cases we might need more than 90% reliability, 99%, 98%. So beta, in that case we can calculate the life at any reliability using this relation. What is this relation? L2 by L1 is equal to natural log of 1 by R2 upon natural log of 1 by R1 whole to the power 1 upon 1.17. This is the relation between life and reliability. Okay, so beta, if you want to see the relation between L50 and L10, then you can do this from here. Okay, for example, at R1 equals to 0.9, 90% reliability, let's say L1 equals to L10, and at R2 equals to 0.5, let's say L2 is equal to L50. So beta, you put it here and you will get this relation. L50 equals to 5 times of L10. If you don't believe me, then you can do it. You can do it yourself. ठीक है, आपको ये वाला relation मिलेगा यहाँ से. Okay, आप अगर R1 और R2 रख दो 0.9 and 0.5, L1 and L2, L10 and L50, then you will get this relation from this equation. L50 equals to 5 times of L10. If you want, you can check it out. ठीक है, अगर आप चाहो तो आप चेक कर सकते हो. But ये मत सोचना कि यहाँ से ये आता है, नहीं, यहाँ से ये निकलता है. Okay, from this relation this is derived. Okay, this relation is not derived from this equation. This equation is derived from this relation. Okay, so L10 equals to 5, L50 equals to 5 times of L10. This is the relation based on which this equation is derived. Okay, and some probabilistic graph, this is derived. Okay, L2 by L1 equals to natural log of 1 by R2 by natural log of 1 by R1 to the power 1 upon 1.17. Now till now there has never been a question from this equation. आज तक इस equation से कोई question आया नहीं है, but अगर आप चाहो तो आप याद कर सकते हो. If you want, you can remember this. Otherwise beta, till now there has never been a question from this relation. Okay, so beta, this is rated life and average life. So I hope this is clear to everyone. I hope सबको clear हो चुका होगा. I hope सबको clear हो चुका होगा. ठीक है, अब equivalent load. Now understand, some bearings are designed to support only radial loads. Some bearings are designed to support only axial load. But there are some bearings which can support both radial as well as axial load. So if there is only radial load, then we can calculate the life of the bearing using that load. What will be the life if the load is this much? Okay, if there is only axial load, then also no problem, we can use that load to calculate the life of the bearing. What will be the life of bearing if the load is acting this much? But the problem is when there is both radial as well as axial load. So in that case, what we need to do, that we need to see. So equivalent load is what? Let's say there is radial load as well as axial load acting on my shaft. So I can't use both these values in order to find the life. I need one single load. So if I convert radial load and axial load into one single load, then that load is known as equivalent load. So read the statement beta, the equivalent load, and this is a dynamic load, okay. Now we are talking about dynamic load. Static load carrying capacity we have seen. Now we are talking about dynamic load. So beta, dynamic load means the load acting on the shaft when the shaft is running. So if the equivalent dynamic load is defined as the constant radial load in case of radial bearing, axial load in case of axial bearing, which if applied to the bearing would give the same life as that which the bearing will attain under actual condition of forces. मतलब कि equivalent load मतलब क्या? If there is radial load as well as axial load, and if I convert these two loads into one single load, then that load will be equivalent load provided that you get the same life under both condition. दोनों condition में life क्या मिलेगी? Same. Means radial load and axial load both are acting and only one single load is acting. In both cases the life will be same. So that load, that single load will be known as equivalent load. ठीक है, तो equivalent load का मतलब क्या है? मेरे bearing पे radial load भी लग रहा है, axial load भी लग रहा है, but I am converting both of them into one single load. Okay, now what is the equation of equivalent load? Equivalent load is given by P. So what is this equivalent load equation? P is equal to V into X into Fr plus Y into Fa, where P is the equivalent load. What are Fr and Fa? Fr and Fa are radial and axial load. X and Y are known as load factors. What do we mean by load factors? These are the factors in order to consider the effect of radial and axial load. What will be the effect of radial load? How much damaging will be the radial load? How much damaging will be the axial load? Because see, it is not necessary that radial load and axial load will give the same damage to the bearing, right? Radial और axial दोनों लोड से हर bearing पे उतना damage नहीं होगा. हो सकता है it might happen that in some case, in some bearings, radial load is more damaging and in some bearings axial load is more damaging. So according to their damage, according to their effect on bearing, there are values of X and Y for every bearing, load factors. Okay, this is given in the design data book. You don't need to remember them. This is given in the design data book. Now what is this V? X and Y are load factors to consider the effect of Fr and Fa. That is clear. But what is V? V is known as race rotation factor. Race rotation factor, its value is equal to 1 if inner race rotates, and it is equal to 1.2 if outer race rotates. See, yesterday I told you that out of inner race and outer race, usually shaft is connected to inner race, so inner race rotates and outer race is connected to the stationary support, right? Usually this happens that inner race is connected to the moving element and outer race is connected to the stationary element, but in some cases inner race might be connected to the stationary element and outer race might be connected to the moving element. So in that case, race rotation factor means V becomes 1/0.2. Otherwise, usually its value will be 1 by default. If nothing is mentioned, then you will assume its value is 1. Otherwise, if it is mentioned in the question that outer race is rotating, inner race is not rotating, inner race is stationary, then we will multiply 1.2 here. बट डोंट वरी बेटा, देयर हैज नेवर बीन अ क्वेश्चन वेयर यू नीड टू यूज दिस इक्वेशन, ठीक है। ये इक्वेशन आपकी नॉलेज के लिए मैं बता रहा हूं, बट आज तक कभी इसके ऊपर क्वेश्चन नहीं आया है, ओके। देयर हैज नेवर बीन अ क्वेश्चन फ्रॉम दिस, ओके। सो डू यू अंडरस्टैंड इक्विवेलेंट लोड? नाउ व्हाई वी आर डिस्कसिंग अबाउट लोड? सी बेटा, if you calculate the life of bearing, then you will apply some load, right? अगर आप life of bearing निकाल रहे हो तो आप कुछ लोड लगा के निकालोगे ना। If you are just running the bearing without applying any load, then it will have infinite life. It will be running and running and running. So beta, we are testing the bearing by applying some load, right? Some load is acting and then we are getting some life. So there must be a relation between load and life. Now general relation will be what? Generally speaking, if the load is increasing, the life should be increasing or decreasing. अगर मैं load बढ़ाऊंगा, if the more load is acting on the bearing, the life will be more or less. If the load is increasing, obviously the life will be decreasing, right? So the life is inversely proportional to load, but there must be some particular, some specific relation. ठीक है? There must be some specific relation between the load and life. So what is that relation? So let's see load life relation. So what is load life relation? It is a relationship given between the rated life and the equivalent load. Rated life और equivalent load के बीच का relation है ये, and this relation is given by L10, यानी कि rated life L10 is equal to C by P whole to the power n, and this is the most important relation in rolling contact bearings, because beta maximum numeric, maximum क्या, all the numericals till now from rolling contact bearing has been from this equation only. जितने भी न्यूमेरिकल आए हैं आज तक वो सिर्फ इसी रिलेशन से आए हैं। जितने भी न्यूमेरिकल आए हैं, all those numericals are from this relation only. L10 equals to C by P whole to the power n, okay, where L10 is rated life, that is clear. P is equivalent load, that is also clear, okay. L10 is rated life, L10 is rated life, P is the equivalent load. But what is C and N? So understand, C is dynamic load carrying capacity. I will give you the definition later, what is dynamic load carrying capacity, but understand that this is like a property of bearing. Just like there are properties of material, right? Young's modulus, modulus of rigidity, Poisson's ratio, just like that, this is also a property of bearing. It is constant for bearing, means whatever life and load you are putting in this equation, C will be constant for a particular bearing. मान लो एक bearing है, उसके लिए C fix रहेगा, okay. If you apply different P, you will get different L, but C will be fixed for that bearing, okay. So C is like a property of the bearing, which is known as dynamic load carrying capacity. Now this N is a constant which is equal to 3 for ball bearing, and it is equal to 10 by 3 for roller bearing. So it is a constant value, 3 for ball bearing and 10 by 3 for roller bearing, okay. So beta, for different values of equivalent load, you will get different lives, okay. Now what will be the direct relation between life and load? Direct relation means if I have different life and different load, what will be their ratio? Understand, L10 will be inversely proportional to 1 by P to the power n, because C is constant. So L10 will be inversely proportional to P to the power n, right? Directly proportional to 1 by P to the power n, or you can say inversely proportional to P to the power n. So I can write L2 by L1 is equal to P1 by P2 whole to the power n. L2 by L1 is equal to P1 by P2 whole to the power n. Means if you have one life at any one load, then you can calculate the second life at the second load. मतलब मान लो, let's say I give you the life at 10 kilonewton and I ask you what will be the life at 20 kilonewton, then you can use this equation. ठीक है, अगर मैं आपको 10 किलोन्यूटन पे लाइफ दे दूं और 20 किलोन्यूटन पे पूछूं, then आप बता सकते हो कि वो लाइफ क्या होगी, what will be that ratio using this equation. Okay, so do you understand this? L10 equals to C by P whole to the power n, and L2 by L1 equals to P1 by P2 whole to the power n. The numericals from rolling contact bearing will be only from these equations. ठीक है, जो भी न्यूमेरिकल आएंगे वो सिर्फ इन्हीं रिलेशन से आ सकते हैं और किसी रिलेशन से न्यूमेरिकल आपको नहीं पूछे जाएंगे. दैट इज माय गारंटी. ओके, ये मेरी गारंटी है, और किसी रिलेशन से न्यूमेरिकल नहीं पूछे जाएंगे. तो आपको सिर्फ ये रिलेशन याद रखना है. You only need to remember these relations. Okay, L10 equals to C by P whole to the power n, L2 by L1 equals to P1 by P2 whole to the power n. Okay, so do you understand this? ये clear है, यहां तक clear है? Okay, now beta, dynamic load carrying capacity. I told you that I will give you the definition of dynamic load carrying capacity. So what is dynamic load carrying capacity? It is like a property of bearing that I told you, but exactly what is dynamic load carrying capacity? Dynamic load carrying capacity है क्या? So it is the equivalent load at which the rated life of bearing is 1 million revolution. ये क्या है? It is the equivalent load at which the rated life is 1 million revolution. For example, if the dynamic load carrying capacity is 50 kilonewton, अगर dynamic load carrying capacity 50 kilonewton है, तो इसका मतलब if I apply 50 kilonewton load, then I will get 1 million revolution rated life. If I apply 50 kilonewton load, then I will get 1 million revolution rated life. Okay, remember that life is always calculated in million revolution. In these equations, life has to be put in million revolution. Okay, 1 million revolution means 10 to the power 6 revolutions. Okay, so do you understand what is dynamic load carrying capacity? It is the equivalent load at which the rated life is 1 million revolution. It is like a property of the bearing. Let me drink water. It is like property of material. आजकल बहुत प्यास लगने लगी है, पता नहीं क्यों, ठंड में भी ज्यादा प्यास लगने लगी है मुझे. Okay, so we are clear about this relation, right? We are clear about this relation. So whatever numericals you will get, you will use this relation only. Okay, and today we are going to solve a lot of numericals. आज हम लोग बहुत सारे numericals करने वाले हैं. So don't worry, आज का जो session होगा, it will be 50% theory and the rest 50% only numericals. I have brought a lot of numericals with me today. Okay, बहुत सारे numericals लेके आया हूं मैं. Okay, चलो. Now let's understand cyclic loading. What do we mean by cyclic loading? Okay, see, in this relation, there is only one load acting on the bearing for its entire life. I am assuming that there is only one load acting on the bearing. One load means, let's say 10 kilonewton, 20 kilonewton, whatever load is acting, but the load is constant for the entire life. But is it necessary? Let's say you are using a machine which is operated for 6 hours per day. मान लो एक मशीन आप चला रहे हो जो 6 घंटे के लिए चलती है पूरे दिन में, but in the morning for 2 hours it is operated at a different speed, a different load. Then in the afternoon the speed and load is changed, and then in the evening it is again changed. So what does it mean? What does it mean? It means that the load is not constant for entire life. For different period of time, different load is acting. Let's say for 20% time a different load is acting, for 30% time a different load is acting, and for the rest 50% time a different load is acting. So this type of loading is known as cyclic loading. So do you understand what I am saying? In order to understand this, what we are going to do is, we are going to make a table. ठीक है, एक टेबल बनाते हैं. Let's make a table. In this table, I am going to put the load, different load acting on the bearing, there will be different speed, and there will be percentage time for which that load is acting. Okay. So let's say this is the load. Okay. This is the speed. Let's say RPM. Okay. Speed in RPM. This is the percentage time for which the load is acting. And let's say this is revolution in 1 minute. Okay. So let's say there is P1 load acting at N1 RPM, P1 load acting at N1 RPM for 30% time, and P2 load acting at N2 RPM for 70% टाइम. ठीक है, मान लो दो अलग अलग लोड हैं जो दो अलग अलग आरपीएम पे लग रहे हैं, दो अलग अलग परसेंट. मान लो इनिशियली व्हेन आई कम टू द ऑफिस or whatever factory wherever I am working, I operate the machine at a different load and speed for 30% of the time. Then after 30%, the rest 70% of the day, I keep it at P2 and N2 speed. Okay, the load is also different, the speed is also different. Okay, now understand. First, what I will do is, at this speed, it is only running for 30% time. So how many revolutions is it going to make in 1 minute at this speed and this speed? Understand. Let's say the bearing is running at 100 RPM for 100% time. Let's say the bearing is running at 100 RPM for 100% time. So how many revolutions will it make in 1 minute? 100. अगर बियरिंग 100 आरपीएम पे चल रही है पूरे 100% टाइम, तो वो एक मिनट में कितने रेवोल्यूशन करेगी? इन 1 मिनट इट विल मेक 100 revolutions if it is running at 100 rpm for 100% time. But if it is running at 100 rpm for only 20% time, then how many revolutions is it going to make? If it is running at 100 rpm for only 20% time, then in 1 minute it will only make 20 revolutions, right? In 1 minute it will only make 20 revolutions. If it is running at 100 rpm for 50% time, then it will make 50 revolutions in 1 minute. So beta, how do you reach to this value? Small n1, I will call it small n1, number of revolutions in 1 minute at this speed. So if it is running at n1 rpm for 100% time, n1 will be capital N1, but it is only running for 30% time. So this will be 0.3 times n1. And if it is running at n2 rpm for 70% time, then small n2 will be 0.7 times n2. ठीक है, 0.3 times of n1, 0.7 times of n2. ठीक है, ये चीज क्लियर है आपको? Is this clear to you? Now, equivalent RPM will be equal to how much? Equivalent RPM will be equal to this small n1 plus small n2. ठीक है, so from here I can calculate the equivalent RPM also. Okay, now what do I need to do? I have these two different loads. I need to convert these two different loads into one single load, because I can only use one load in this equation. मैं सिर्फ एक load use कर सकता हूं इस equation में. So I need to convert these two loads. I need to convert these two loads into one single load, right? So for that we have this equation. P equals to P1 cube into N1 plus P2 cube into N2 plus P3 cube into N3. There might be many loads, right? Divided by N1 plus N2 plus and so on whole to the power 1 by 3. This is the equation to convert P1, P2, P3, P4, all of that into one single load P. But this relation is for ball bearing. This relation is for ball bearing. Okay. There is a different relation for roller bearing. In case of roller bearing, this relation becomes P equal to P1 to the power, instead of 3, what I will use? 10 by 3. For roller bearing, it will become 10 by 3. So it will be P1 to the power 10 by 3 N1, P2 to the power 10 by 3 N2, and so on, whole divided by N1 plus N2 and so on to the power 3 by 10. This is for roller bearing. You just need to replace 3 with 10 by 3. Okay? In case of roller bearing, you just need to replace 3 with 10 by 3. Very good Kalpesh. Okay? So 3 की जगह बस 10 by 3 लगा दो and the formula will become for roller bearing. Okay? So this formula is for ball bearing. This formula is for roller bearing. Is it clear to you? So if there is cyclic loading, means different loads for different percentage of time, then you can convert all these loads into one single load. Here I am taking example of only 2 loads, but there can be different number of loads, P3, P4, P5, P6, any number of loads, you can use this formula. Okay? But there has never been a question from this. What did I say? That till now from GATE there has only questions from this equation, L10 equals to C by P to the power n. सिर्फ इस एक इक्वेशन से सवाल आए हैं. You won't believe, जितने न्यूमेरिकल आए हैं आज तक सिर्फ यहीं से आए हैं, आज तक सिर्फ यहीं से आए हैं. ठीक है मेरे भाई नीतीश, 10 by 3 का मतलब 3.33 तो होता है यार. क्या सवाल नीतीश इज आस्किंग मी शैल वी यूज 3.33. अरे यूज कर लो भाई, 10 by 3 मीन्स 3.33 ना. ओके so beta let's solve problems and I have brought all the numericals of GATE. मैं सारे GATE के numericals लेके आया हूं from the recent GATE to very old times. Okay 87 तक के questions, आज तक जितने questions आए हैं till now, whatever questions have been asked from ball bearings, I have brought all those questions for you. मैं वो सारे questions लेके आया हूं और वो सारे question अपन करने वाले हैं. Okay so beta the first question, bring your calculators. I will also bring my calculator, you also bring your calculator. Okay bring your own calculator, BYOC, just like BYOB, if you understand what I mean. चलो तो बेटा कैलकुलेटर अपने साथ रखो क्योंकि अब मैराथन चालू होने वाला है न्यूमेरिकल्स का. A self-aligning ball bearing has a basic dynamic load rating. Dynamic load rating मतलब load carrying capacity of 35 kilonewton. If the equivalent radial load is 45 kilonewton, the expected life in revolutions is, many million revolutions is. Million revolutions में what will be the life of the bearing? Tell me. सबसे पहले तो ये बताओ कि लोड कैरिंग कैपेसिटी 35 किलोन्यूटन है और लग रहा है 45 किलोन्यूटन. सो वेदर इट विल बी मोर देन 1 और लेस देन 1. टेल मी वेदर इट विल बी मोर देन 1 और लेस देन 1. तो सबसे पहले तो बेटा 35 kilonewton is dynamic load carrying capacity, means if you apply this much load there will be 1 million revolution and I am applying more than this, so obviously the answer will be less than 1. ठीक है Palak has already got the answer. Very good. So beta let's use the equation L10 equals to C by P whole to the power n. So what is C? C is 35 and what is P? P is 45 and it is a ball bearing. It is a ball bearing, so n will be 3. So from here what L10 am I getting? 35 by 45 whole to the power 3. It is 0.47, right? It is 0.47. So the answer is below 0.5. Yes, A, below 0.5. Very good. Very good, Dinesh Kumar. Very good, Ankita. Ayush. Very good. Very good, Sweksha. Very good, Dinesh. Very good. Very good, everyone. Very good. Very good. Excellent. So, beta, GATE 2018 का 2 marks का question. Can you believe that this is the equation you need to use? No need of anything else. L10 equals to C by P whole to the power n. This is the only equation all the numericals of GATE till now will be solved by this. ये सिंगल इक्वेशन है, इसी से सारे न्यूमेरिकल सॉल्व करने वाले. पता नहीं मेरे गले को क्या हो गया, छिल गया है या पता नहीं क्या हो गया, बट आई एम नॉट एबल टू शाउट. Okay, so let's move on to the new question. Let's move on to the new question. हाँ, समझ गया. Next question, GATE 2016 1 mark question. Which of these bearings given below should not be subjected to thrust load? इनमें से कौन सा bearing मेरे भाई thrust load नहीं सह पाएगा? Which of these will not be able to sustain thrust load? Deep groove, angular contact, cylindrical roller और single row tapered roller? बताओ. Deep groove, angular contact, cylindrical roller, tapered roller. Which of them will not be able to sustain? Okay, Dinesh Kumar, Kalpesh, Prem, Utkarsh, Palak, Ayush. Yes, Ankita, Vishal. Very good guys, very good. The answer will be C, cylindrical roller bearing. I told you yesterday, you need to just remember these very small, simple characteristics. No need to remember the entire paragraph about that bearing. पूरा पैराग्राफ नहीं रटना है उस बियरिंग के बारे में, उस बियरिंग की पूरी जीवन गाथा नहीं रटनी है. You only need to remember 1 or 2 characteristics. Okay, so if you remember all these characteristics, you know that deep groove ball bearing can sustain radial as well as axial load. Angular contact can also sustain, and tapered roller bearing can also sustain axial load. Only cylindrical roller bearing will not be able to sustain axial load, right? They can only sustain radial load. Very good, Gopala Krishna. Very good, Vikas. Very good, Sveksha. Very good, Akshay. Very good guys. Very good. Next question. For ball bearing, the fatigue life L measured in number of revolution and the radial load F are related by FL to the power 1 by 3 equals to K. In this question, they have also given the relation. इस question में तो हद ही कर दी, relation तक दे दिया है. It withstands a radial load of 2 kilonewton for a life of 540 million revolutions. The load for a life of 1 million revolution is. मतलब क्या बोल रहा है इस इक्वेशन में, for radial load for 2 kilonewton, radial load of 2 kilonewton for life of 540 million revolution. So load for life of 1 million revolution. 1 million लाइफ के लिए कितना लोड लगे, ठीक है. So beta FL to the power 1 by 3 is equal to K. So can I write F1 L1 to the power 1 by 3 equals to F2 L2 to the power 1 by 3, right? So beta F1 means 2 kilonewton load. L1 means 540 million revolution. So F2 that we need to calculate at L2 means 1 million revolution. तो यहां से सिंपल I will get F2, right? यहां से सीधे F2 आ जाएगा. What is F2? 2 into 540 whole to the power 1 by 3. So it is what? 16.28 kilonewton. Very good, Kalpesh. 16.28 kilonewton. 16.28 kilonewton. Yes, 16.28 kilonewton. Yes, Dinesh. 16.28 kilonewton. 16.28 kilonewton. 16.28 kilonewton. Yes. Very good, Palak. Very good, Vishal. Very good, Utkarsh. 16.28 kilonewton. Yes, very good, very good guys. 16.2, very good Gopala Krishna, very good Ayush, very good Pravalika, वेरी गुड प्रेम 16.28 किलो न्यूटन। चलो तो गेट 2015 का क्वेश्चन, इस क्वेश्चन में दे हैव इवन गिवन द इक्वेशन, यू डोंट नीड टू डू एनीथिंग, आपको याद करने की भी जरूरत नहीं। वेरी गुड अंकिता, वेरी गुड विकास। चलो नेक्स्ट क्वेश्चन में बढ़ते हैं। सो दिस इज द नेक्स्ट क्वेश्चन फ्रॉम गेट 2014, 2 मार्क्स क्वेश्चन। ओके सॉरी, लीव दिस क्वेश्चन, दैट वाज फॉर जर्नल बियरिंग, वो परसों करेंगे। ओके जर्नल बियरिंग के क्वेश्चन कल या परसों करेंगे। ओके अ बॉल बियरिंग are rated by manufacturer for a life of 10 to the power 6 means 1 million revolution. The catalog rating is 16 kilonewton. So what is this? What is this? Catalog rating is 16 kilonewton means this is the load carrying capacity. ये क्या दिया हुआ है? What is this? This is the load carrying capacity C. Okay, dynamic load carrying capacity. Catalog rating मतलब catalog में what do they mention? Catalog में they mention the dynamic load carrying capacity. Okay. If the design load means this is the load actually acting, this is the load of bearing, catalog load, and this is the actual load P. This is what P. The life of bearing will be P into 10 to the power 6 revolution, where P is equal to कितने million revolutions life आएगा, बताओ कितने million revolutions life आएगा? Calculated. Gate 2014 only 1 mark question. Tell me, simple relation L10 equals to C by P whole to the power n. What is C? 16 kilonewton. What is P? 2 kilonewton. What is n? It is a ball bearing, so 3. So 8 to the power 3. 8 to the power 3. 512 million revolution, right? 512 million revolution. 512 million revolution means answer will be 512 into 10 to the power 6 revolution ना, मतलब million revolution into 10 to the power 6 मतलब million revolution. Okay, yes, 512 million revolution. Very good Utkarsh, Vishal, very good Narayani, very good Prem, very good Jitendra, very good Vinay, very good बहुत बढ़िया, वेरी गुड अंकिता, वेरी गुड नीतीश, वेरी गुड दिव्यांशु, वेरी गुड, बहुत बढ़िया। 512 मिलियन रेवोल्यूशन, एक ही मार्क का क्वेश्चन था, बहुत सिंपल क्वेश्चन था। लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन एंड दिस इज फ्रॉम गेट 2011, 2 मार्क्स क्वेश्चन। गेट 2011 का क्वेश्चन है, 2 मार्क का क्वेश्चन है। ओके अंडरस्टैंड, 2 आइडेंटिकल बॉल बियरिंग्स P and Q are operating at loads 30 kilonewton and 40 kilonewton. The ratio of life of bearing P to life of bearing Q is, तो मेरे भाई लाइफ ऑफ बियरिंग P and Q निकालना है, तो ये ऐसा हो जाएगा लाइफ ऑफ P डिवाइडेड बाय लाइफ ऑफ Q इक्वल्स टू लोड ऑफ Q डिवाइडेड बाय लोड ऑफ P। तो लोड ऑफ Q कितना है? लोड ऑफ Q इज 45 डिवाइडेड बाय लोड ऑफ P इज 30 होल टू द पावर, बॉल बियरिंग इट इज 3. So what will be this relation? 45 by 30 whole to the power 3, it will be 27 by 8. Yes, 27 by 8. Yes, Narayani, 27 by 8. Yes, very good. 27 by 8. The answer will be 27 by 8. Gate 2011, 2 marks question. Very good, Dinesh. Very good, Palak. Very good Kalpesh, 27 by 8. Very good Utkarsh, 27 by 8. 27 by 8. B is the answer, 27 by 8. अरे मेरे भाई पढ़ लो पहले, ऑप्शन में क्या दिया है, 3.375 बोले जा रहे हो, पढ़ लो पहले। वेरी गुड गोपाल कृष्णा, वेरी गुड अंकिता, वेरी गुड प्रेम, यस विशाल, 27.8 यानी कि द आंसर इज बी। ठीक है, 27.8. ओके वेरी गुड स्वेक्षा, 27.8। चलो नेक्स्ट क्वेश्चन की तरफ बढ़ते हैं। गेट 2007, 2 मार्क्स क्वेश्चन। गेट 2007 का क्वेश्चन है, 2 मार्क का क्वेश्चन है। अ बॉल बियरिंग ऑपरेटिंग एट अ लोड F has 8,000 hours of life. Life of bearing in hours when the load is doubled. See, sometimes they give you the life in number of hours. No problem, no issue. You know, you want the answer in hours only, so you can directly use the formula. Okay, the life of bearing, load is given F and 2F. तो बेटा यही हो जाएगा L2 by L1 equals to P1 by P2 whole to the power n. Okay, तो hours में दिया है life, तब भी वैसे ही रख दो. तो L2 we need to calculate. What is L1? Life before 8000. Okay, now earlier the load was F and now the load is 2F. Okay, whole to the power 3. It is ball bearing only. So what will be L2? What will be L2? What will be L2 beta? What will be L2? Yes, it will be 1000 hours. It will be 1000 hours. 1000 hours. 1000 hours. D will be the answer. So GATE 2007 2 marks question. Yes, 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 Nitish. Sorry, yes, Dinesh, yes, Palak, yes, Kalpesh, yes, Sweksha, yes, Ayush. 1000 hours. Yes, Utkarsh, yes, Prem. 1000 hours. Yes, Narayani. 1000 hours. Yes, Dibyanshu. 1000 hours. So beta, you can see that in every question of GATE, there is only one relation you need to use. Okay, and I am not skipping any question. I have brought every question of GATE. मैं सारे क्वेश्चन गेट के लेके आया हूं. मतलब एक भी क्वेश्चन ऐसा नहीं है जो मैंने जानबूझ के छोड़ दिया कि इसमें कुछ और फॉर्मूला लग रहा है तो मैं छोड़ देता हूं. नहीं, मैं सारे क्वेश्चन लेके आया हूं. तो आप देख सकते हो सारे क्वेश्चन में सिर्फ एक और एक रिलेशन. देयर इज ओनली वन सिंगल इक्वेशन व्हिच यू नीड टू यूज इन एवरी क्वेश्चन. यस प्रवल्लिका, यस अंकिता, यस विशाल, वेरी गुड. 1000 आवर्स. यस अक्षय, 1000 आवर्स. ओके, चलो नेक्स्ट क्वेश्चन. गेट 2000 का क्वेश्चन है, 2 मार्क्स का क्वेश्चन. गेट 2000 2 मार्क्स क्वेश्चन. लाइफ ऑफ बॉल बियरिंग at a load of 10 kilonewton is 8000 hours. If the load is increased to 20 kilonewton and all the condition are same, what will be the life? अब तो आप मौखिक बता सकते हो. Even without solving you can tell. If you double the load, what will be the life? The life will become 1 by 8 times na. If you double the load, the life will become. अच्छा, this is the same question. This is the same question. Only in this case they have given the F. इस बार बस वो F दे दिया है उन्होंने. ओके, इस बार बस वो F दे दिया है उन्होंने. सेम क्वेश्चन है, सेम क्वेश्चन है. C will be the answer, right? Yes, C will be the answer. 1000 hours. If you double the load, the life will become 1 by 8 times. Yes, yes, yes. C will be the answer. 1000 hours. See, same question, but in this question they have given F and 2F. Here they have given 10 and 20 kilonewton. Chalo, chalo, chalo. Next question. The dynamic load capacity of 6306 bearing. This is known as SKF bearing. This is an SKF bearing designation. I will tell you what is this designation. Okay, designation का मतलब मैं कल समझाऊंगा आपको. So बेटा, dynamic load capacity 6306 bearing is 20 kilonewton. अभी थोड़ा सा समझा देता हूँ. 6 means it is a deep groove ball bearing. 3 is the series of shape and size. Size के लिए there are different series. So it is the 3 series. The जो series है वो 3 है, and 0.6 multiplied by 5 will give you the inside diameter. Okay, the bore diameter means the bore diameter is 30 mm. ठीक है, the diameter of inner race is 30 mm. Okay, so a 6306 bearing is 22 kilonewton. Dynamic load carrying capacity 22. Maximum radial load it can sustain at 600 revolution per minute for 2000 hours. अब यहाँ पे ध्यान दो. L10 will be equals to C by P whole to the power n. Now here they have not given the life in million revolution. Here they have mentioned the life in revolution per minute and hours. अब बेटा यहाँ we have to convert it in million revolution. Understand? 600 revolution in 1 minute. 600 revolution in 1 minute. So in 1 hour, how many revolution? In 1 hour, 600 into 60. 600 revolution in 1 minute. So in 1 hour, 600 into 60. So in 2000 hours, 600 into 60 into 2000. These are number of revolution, but we have to convert it in million revolution. अपने को इसको million revolution में convert करना है. तो multiplied by 10 to the power minus 6. Don't forget this. ये मत भूल जाना. We have to convert it in million revolution equals to C. यानी 22/p होल टू द पावर 3. It is a ball bearing. 6306 means it is ball bearing. Okay, deep groove ball bearing. The first letter 6 is deep groove ball bearing. Okay, so from here you can calculate the value of p. Okay, I will tell you this designation, bearing designation. मैं bearing designation बताऊंगा आपको. ठीक है, तो क्या आ रहा है आंसर बेटा? What is the answer? What is the answer? 22 whole to the power 3 divided by 600 into 60 into 2000 into 10 to the power minus 6 under cube. 5.29 kilonewton, 5.288 kilonewton आ रहा है. So around 5.29 kilonewton, right? Around 5.29 kilonewton. So GATE 1997 2 marks question. Yes, Ankita, Utkarsh, Prem, yes, Vinay, yes, Palak, yes, Kalpesh, yes, Dinesh, yes, Dibyanshu, yes, Narayani, yes, Vishal, yes, Utkarsh, very good, very good. 5.29 kilonewton, 5.29 kilonewton, very good. Ayush, 5.29 kilonewton, 5.29 kilonewton, very good. So beta, very simple question from GATE 1997 2 marks question. Okay, so shall we move on to the next question? Next question की तरफ चलें, next question की तरफ चलें. चलो, yes, Ayush, yes, Feksha, very good. Next question from GATE 1987. This is the oldest question. ठीक है, this is the oldest question. 1987 का 2 marks का question. Expected life of a ball bearing subjected to a load of 9800 Newton and working at 1000 RPM is 3000 hours. What is the expected life subjected to 4900 RPM, 4900 Newton at a speed of 2000 RPM? तो यही वाली equation L2 by L1 equals to P1 by P2 whole to the power n. Now beta understand, life is RPM into 60 into hours into 10 to the power minus 6, right? RPM into 60 into hours into 10 to the power minus 6. Now when I will take ratio of two life, 60 and to 10 to the power minus 6 will cut. So you will get RPM into hours. ये क्या है मेरे भाई? This is RPM, this is hours. So RPM into 60 into hours into 10 to the power minus 6. If RPM and hours are given, then you can convert life. अब बेटा 60 and 10 to the power minus 6 will cancel because we are taking ratio. तो बेटा यहाँ पे RPM into life मिलेगा. So second वाला RPM is what? Second वाला RPM is 2000. Second वाला hours मेरे को नहीं पता है, तो I will write it H2. Okay, second times hours. First वाला RPM is 1000 and first वाला R is how much? First वाला R is 3000. Okay, equal to first वाला load 9800, second वाला load 4900 whole to the power, what is n? N is 3. So from here you will get H2, second वाला hours. You will get H2, second वाला hours. कितना आ रहा है? 12,000 hours. 8 into 1000 into 3000 divided by 2000. 12,000. H2 will be 12,000 hours. H2 will be 12,000 hours, right? Yes. Yes, Narayani, Palak. Yes, Kalpesh. Very good. Very good, Prem. Very good, Dibyanshu. Very good, Vijay. Very good, Jitendra. Very good, Utkarsh. Very good, Sweksha. Very good, guys. Very good. Very good. अरे hit the like button यार. I have solved so many questions for you. इतने सारे क्वेश्चन करा लिए और सारे क्वेश्चन कर लिए गेट के. अब तो सबको एक एक लाइक दे दो. अब तो सबको एक एक लाइक दे दो. घर लेके जाओगे. यस अंकिता, यस नीतीश, यस वेरी गुड विनय. अब तो सबके सब एक एक लाइक दे दो और सबके सब शेयर भी कर डालना. सबके सब शेयर भी कर डालना. सिर्फ लाइक करके छोड़ मत देना, ठीक है? ये सारे लेक्चर्स, इस पूरी प्लेलिस्ट की लिंक दो, कॉपी करो और शेयर मारो. सबको पहुंचाओ यार, घर घर तक पहुंचने चाहिए ये लेक्चर्स, ठीक है? और ये आपकी जिम्मेदारी है, सिर्फ मेरी नहीं. वेरी गुड, वेरी गुड. चलो, बहुत बहुत बढ़िया. कम से कम 50 भी नहीं यार क्रॉस करते आजकल. हाँ चलो, 50 तो क्रॉस हुआ. कम से कम 50 तो क्रॉस किया करो. पहले तो 100 क्रॉस हो जाते थे फट से. अब देख लो, मारा मारी हो रही है इतनी. चलो कोई बात नहीं, चलो कोई बात नहीं. अरे मेरे भाई सलमान से बात करने वाले, यहाँ बॉल बियरिंग दिया है ना, तो N3 लेना है ना फॉर बॉल बियरिंग, ठीक है। चलो तो बेटा रोलिंग कॉन्टैक्ट बियरिंग के जितने पॉसिबल क्वेश्चंस थे, ऑल द पॉसिबल क्वेश्चंस वी हैव सॉल्व्ड, ओके, ऑल द पॉसिबल क्वेश्चंस फ्रॉम गेट वी हैव सॉल्व्ड, ओके। अब कल मैं आपको बताऊंगा, टुमारो आई विल टेल यू, टुमारोज क्लास, टुमारो एट 7:30, tomorrow at 7:30 I will tell you the SKF bearing designation. आपने ये जो designation देखा ना 6306 bearing, so what does this mean? इसका क्या मतलब है, इसका क्या मतलब है, इसका क्या मतलब है, all of this I will let you know tomorrow at 7:30 rpm, okay, sorry 7:30 pm. And beta, a very important news, we have started the crash course, sorry so sorry, माइक निकल गया. So we have started the crash course on theory of machine from 14th of December. Every day I am taking 2 lectures, okay, Monday to Saturday the classes will be held at 2 p.m. and 3:30 p.m. So everyone is welcome. These are free of cost lectures. These are completely free of cost lectures. Everyone can join us. These are completely free. Everyone can join us. All you need to do is download the Unacademy learning app and use the invite code Apuroop10. ये invite code use कर लेना Apuroop10 and you will be able to watch this class, okay. And where will you get the link of this class? Where will you get the link of this class? This class is on Unacademy. Where will you get the link? Either you follow my Telegram channel, या तो मेरा Telegram channel follow कर लो, okay. This is my personal Telegram channel. So open your Telegram app and search Apuroop10. You will find my Telegram channel. So I will post the links in all these Telegram channel, or you go to tinyurl.com/Apuroop10. just यहाँ चले जाओ, यहाँ चले जाओ, यहाँ चले जाओ, tinyurl.com/Apuroop10. I will tell you how to open this, ठीक है. इसको ओपन कैसे करना है ये मैं फट से बता देता हूँ. I will tell you how to open this, okay. So just type tinyurl.com/Apuroop10. you can see tinyurl.com/Apuroop10 and enter, and you will open this, where you will find the folders of ebooks and you will find all these Excel sheets. So open this Tom Crash Course Excel sheet. Tom Crash Course Excel sheet, if you open, then you will see that I have uploaded the links of all classes. I have uploaded the links of all classes, okay. So tomorrow 18th of December 2 p.m. and 3:30 p.m. there are 2 lectures, velocity analysis 3, velocity analysis 4. If you go to this link, then it will ask you, there are 17 hours and 3 minutes left for this class. Click on notify me. If you click on this, he will ask you to log in. So if you have already registered, log in. If you have not registered, please register yourself and then click on notify me button, okay. Click on notify me button, okay. So beta, don't forget to join us tomorrow at 2 p.m. and 3:30 p.m. for theory of machine class, okay. And a very important news, there are new batches on Unacademy Plus. Unacademy Plus की new batches चालू हो रही हैं from 28th of December. 28th of December there is one batch for GATE 22 aspirants, Evolve batch, and one batch for GATE 23 aspirants, Ascend batch. So join these batches on Unacademy Plus. Take the Unacademy subscription using the code Apuroop10, okay. Only legendary teachers will be teaching in these batches. सिर्फ top educators in batch पे पढ़ाने वाले हैं. So join Evolve and Ascend batch for GATE 22 and GATE 23, okay. And what will be the benefit of Unacademy Plus? Why Unacademy Plus? Unacademy Plus पे क्यों आना है? बेटा Unacademy Plus पे you will be getting batch courses. Entire syllabus will be covered, and that too only by the top educators of India. And there are many batches. It will be your choice which batch you want to study. There will be live classes in English as well as in Hindi. So no language barrier. There will be weekly test in every subject. There will be doubt solving. There will be crash courses. So beta, if you don't take Unacademy Plus subscription, you will not get rank. That is not true. You can get rank on your own also. आप खुद से भी पढ़ के रैंक ला सकते हो, लेकिन जब आप Unacademy Plus पे इन बैच कोर्सेज में पढ़ते हो टॉप एजुकेटर्स, क्वालिटी एजुकेटर्स से पढ़ते हो, जब आप इन एक्सपर्ट्स की गाइडेंस में पढ़ते हो, तो आपका जो एफर्ट है वो कम हो जाता है, आपका आउटपुट बढ़ जाता है। आप जो गलतियां करने वाले हो, आप जो चीजें पढ़ने वाले हो, वो सारी चीजें आपको पहले से बताई जाती हैं। क्या पढ़ना है, क्या छोड़ना है, ये सारी चीजें आपको पहले से बताई जाती हैं। सो द मिस्टेक्स दैट यू आर गोइंग टू कमिट, you will not commit those mistakes, you will save your time, you will save your effort. So beta, it is not true that you cannot get rank without this. Yes, you can get rank without this, but if you are studying under the experts, then beta, it will improve your chances of getting rank. And one step ahead of this is iconic subscription, where you get a personal coach who will plan your entire schedule. पूरा आपको schedule बना के दिया जाएगा, who will take one-on-one sessions, who will analyze your test score, what you did right, what you did wrong, and who will prepare study material for you. So Unacademy Plus and Unacademy Iconic subscription will get you that guidance of experts. And what else will you get on Unacademy platform? Why Unacademy platform is India's #1 learning platform? Understand, it was designed only for learning. So there are a lot of tools which are available here which will be helping you in learning. For example, live polling and leaderboard, where whenever you have objective questions, a live poll will be created. You will answer A, B, C, D. So beta, the leaderboard will tell you what is your rank and what is your timing of answering. So this will improve your time management, this will improve your answer giving skills, and this will create a healthy competitive environment in the class. So beta, learning will become really fun for you in the class of Unacademy. Then live interaction and dedicated doubt solving sessions. Live interaction means you can interact with the teacher live in the class. You can ask your doubts live in the class in the comments, and you can also send the question in image form. आप क्वेश्चन को इमेज के फॉर्म में भेज सकते हो ताकि आपको लिख के क्वेश्चन पूछना ना पड़े। तो सारी चीजें आप डाउट सारे पूछ सकते हो टीचर से, एंड देयर विल बी डेडिकेटेड डाउट सॉल्विंग सेशन, मींस every 4th lecture will be a doubt solving session. So बेटा, none of your doubts will be unanswered. आपके सारे doubts answer किए जाएंगे. आपको कभी ये complain नहीं होगी. You will never have this complaint that you are not getting enough time to ask doubts, because there are dedicated doubt solving classes. Then there are multiple batches, not only 1 or 2 batches, multiple batches by the top educators on Unacademy Plus. You can see these are the batches of top educators. You can watch my batch also. So beta, these batches, all these batches you can join. There is batch for GATE 21, GATE 22, GATE 23, ESE. There is a batch for rank improvement. So beta, these are different batches. You can join any of these batches or all of these batches. It is up to you. If you want, you can join all of them. So beta, don't wait and take your decision as soon as possible. Start your preparation as soon as you're possible with these top educators of India. Okay. So beta, go to your Unacademy learning app, click on get subscription. You will see different subscription plans. Okay, 1 month से लेके 2 year तक के plan. But if you ask me, I will suggest take this 1 year, 1.5 year or 2 year plan. Okay, this is the long term plan because per month cost is very less. Okay, and you will get enough time to cover all these batches. And if you enter referral code Apuroop10, if you enter referral code Apuroop10, you will get 10% instant off. So this will become 30,000 will become 27,000, 38,000 will become 34,000 something, and 44,000 will become 39,600. Okay. So beta, if you use this code Apuroop10, you get 10% instant off, and you will get my personal guidance. I will guide you personally. I will tell you in each and every step what you need to do. I will personally mentor you. Okay. And you can pay this fees in EMI also, no cost EMI. No cost EMI means no additional cost. आपको एक पैसा भी एक्स्ट्रा नहीं देना है. आप ये पूरा फी जो है EMI में भर सकते हो. 1 year से लेके 2 year तक का EMI available. Okay. So बेटा, don't wait and join Unacademy Plus as soon as possible. Start your preparation with the top educators. Start your preparation with the top students. Okay. But before going, and you can also take Unacademy Iconic subscription using my code Apuroop10. Okay, there is Unacademy Iconic subscription also. 1 year subscription will cost you 40,000 and 2 year subscription will cost you 54,000. Okay, so before leaving beta, hit the like button, share this link, and subscribe to this channel. Thank you so much for joining. I will see you tomorrow. Till then, bye bye. Take care. Good night.